Hi everyone. Today we are going to discuss about dataset of the cirrhosis. So firstly, let me briefly introduce about the dataset I chose. So the dataset contains information collected from Mayo Clinic primary biliary cirrhosis of the liver conducted between 1974 and 1984. So it contains key features such as demographics, clinical findings, laboratory results, and disease stage. So the purpose of using this dataset is to develop a classifier that can predict whether a patient will develop a cirrhosis based on their clinical and laboratory data. So this can really helps in early detections, risk assessment, and also personalized treatment of the PBC. So next, I will break down the dataset, pre-processing and modeling step by step in order to you to understand better. So we implement a very general data cleaning process and also the categorical data conversion. So the first thing we do is to handling missing values. So for numeric features like days, age, and bilirubin, any missing values are replaced with zero. And for the category features like drug or sites, we use zero as a placeholders. So this really ensure that no missing data will disrupt our analysis. And next, we encoding the target variable. So the stage columns, which represent this stage, is simplified into a binary classification problem. So the stage 4 is coded as 1 and indicating that a cirrhosis, while all other stages are coded as 0, means no cirrhosis. And for the skewness, any skewed numerical features can impact the result. So we apply a log transformation to those who have a significant skewness. Though this really reduce the effort if the effect of the very extreme values and giving us a more balanced data set. We also covered processing outliers. We use Turkey rules to identify outlier based on IQR. Once identified, we handle them with a technique called winsorization, which caps extreme values to keep things manageable. So we moving to our categorical features. We use a one-hot encoding to convert category like drug, sex, sites into numeric representations. This really create binary columns for each category, making the data ready for modeling subsequently. And we balancing our data set, we check for the class imbalance between cirrhosis and non-cirrhosis cases. And if we find any, we apply mode and we balance the training data by increasing the minority class. And now let's dive into the modeling. So first, the experimental setup, we split the data into training and testing sets using train test split. And on the training data, we apply standardizations with standard scalar and balance our classes using smooth, ensure that we have a very solid foundation for the model performance. Then we use a decision tree classifier, which in the model using the pipeline that includes scaling, mode, and classifier itself. And the results are evaluated and the test set up using metrics like accuracy and fusion matrix. And finally, we explore PyCaret by model selection. With PyCaret, we compare, we select, we turn, and evaluate multiple models in just a few steps. And using those setup functions, we configured the experiment to include the data splitting, normalizations, and class imbalancing. Then we compare models, identify the best performance models, and we further turn and then finalize. So the finalized model is used for our eventual prediction and evaluation on the test sets. So as you can see, the advantage of using PyCaret is very clear. It's highly automated and requires less work, which means it's more easier to implement. So in addition, model comparison itself make us to easier compare multiple models effortlessly, especially fit into our dataset because PyCaret is very good fit for those small and medium-sized datasets, such as our dataset with only 418 rows and 20 columns. And it's simplified and especially designed for classification tests. And our dataset is about binary classification problems regarding cirrhosis. So it can easily get the best performing models by using carrots and saving us a lot of time and efforts. So the outcome and result of these models give us very practical insights in real worlds, such as the bilirubin appears to be one of the most features and indicators for cirrhosis based on the correlation heat map. This result can be used for early detections and the diagnosis. And this classifier can assist doctors for a timely interventions. Moreover, the classifiers help us to personalize treatment plans. So those important indicators can be affected by patient's diet or lifestyles. It provides directions for those patients to improve those lifestyles. And lastly, there are also other underlying patterns for cirrhosis research. So the classifier really provides a very good opening for the research. So thank you very much.